Hello everybody, welcome or welcome back to my channel. In today's video of episode 5 of Introduction to Software Engineering, we'll be seeing topics including why requirements matter, gathering requirements, requirements analysis, functional requirements, non-functional requirements, the SRS document. So let's quickly begin. This is a beginner friendly and very easy to understand series which I have made for Introduction to Software Engineering. So I hope you like it as well. So first of all, why requirements matter? We all know the exact meaning of requirements. That is basically what do you require, what do you need, necessities. Those are basically requirements. So imagine building a house without ever asking the owner how many bedrooms they want. So unbelievable, right? So you might build a beautiful house, just the wrong one. That's the problem. Tearing down a wall after construction is far more expensive than changing the blueprint before you have laid a single brick. Yes or no? Imagine after you've built the whole thing, now you want to reduce a room or add a room, and then you start breaking down things. That's far more chaotic, far more expensive than just changing the blueprint, giving out correct necessities, what do you require, stating your requirements before even single brick is laid, before even construction begins. That is what we're trying to say. Requirements are that blueprint for software. They define exactly what the system must do before anything starts building. So what happens without good requirements? So without if good requirements are not given, then developers guess, they assume, which is increasing the risk of mistakes. Because when you assume, when you guess, they can be right, they can be wrong. So there is a chance of mistakes. Requirements keep changing late in the project, causing delays. The delivered product doesn't match what the customer actually wanted. Customers' trust is damaged, sometimes leading to disputes. All are self-explanatory. So what good requirements give you? Why do we require why do we require requirements? First of all, customer expectations match what actually gets delivered. Fewer misunderstandings between everyone involved, not just between the user and the whoever develops it, also between the developers, also between the team of who is building it. The misunderstandings are reduced. No wasted effort building features nobody asked for. Imagine you don't have clear requirements, you just assume the customer might like the house built like this. I'm just giving an example of a house, it's obviously based on software. And you start making your own imaginations, own whatever you want to start building in that house, and the customer didn't really even ask for. That's all waste, right? Effort waste, money waste, products waste, all of it is waste. So higher quality software with fewer risks and delays are built when good requirements are given. So the cost of a mistake explodes over time. How? If you change during the requirement time, an error code during the requirement stage is cheap to fix. Basically, it's an edited document. Suppose the house asked for the owner asked for a 4 BHK. You have planned a 2 BHK. Just change the layout, change what you want, change the blueprint, make it to 4 BHK. You're done. Very few costs required to change that. Same in the design. Okay, the designing is already done. Now you want changes. It's going to be a little more costlier than the requirement stage, but it's still doable. It's not that problematic. Coding stage. Let's say that's the construction stage. You start building. Now you want some change. Okay, only a few bricks are laid. It is problematic, but okay, we can think about something. So as we increase, as the product is coming to an end, the cost of making any change in it is going to become higher. That's basically what I'm trying to say. Same error found in the maintenance is when after you have built the whole project, after testing all of that is done, and then you're trying to fix some bugs. At that time you're trying to change the whole core idea of the project. It's going to cost you 10 to 100 times more than what it was costing in the requirement stage. Why? Because design, code, and test were all built on the wrong assumption. All of it needs to be redone. Okay? So the earlier you catch a requirement mistake, the cheaper it is to fix it. That's the hashtag one reason this phase deserves So much care, so much attention, so much importance. Let's try to answer the question. Why is fixing a requirement error during maintenance so much more expensive than fixing it early? We have learned it. So, because design code and tests were all already built on the wrong assumption but now need reworking only because the requirements was not clearly listed down, was not clearly given. Okay, that's the answer. Every phase after requirements builds on top of it. So, an early mistake ripples through design, coding, testing, multiplying the rework needed. Absolutely. The next part is requirements gathering, which is also called as elicitation, the process of collecting raw information from the people who actually know what they need. Of collecting people who actually know what they need. Think of it like interviewing witness to piece together a story. No single witness saw everything. Absolutely. One person knows part of the picture, another knows a different part. A system analyst's job is to talk to everyone involved and stitch their fragments into one clear, complete story. Who does that? A system analyst. Now we'll understand who are stakeholders. So, stakeholders are any person or anyone who's affected by the system directly or indirectly. It could be the end users, who are the users who are going to use the software you have developed. People who use the system daily. Managers who oversee the operations and decisions. As a head, they see what all is happening, they oversee all the operations. Technical staff who build and maintain the system. These are the stakeholders. So no single stakeholder knows the whole system. Each one only sees their own corner of it. Suppose think of this as a, one second. Think of this as a square. Here end users are sitting. Here managers are sitting. Here technical staff is sitting. Here someone else is sitting. So everyone is concerned about, suppose end users, they only care about what is given to them as an output and how they can work with it. Managers will is main thing is to operations and decisions. They are the ones who will build and maintain the system, technical staff. So each one is having their own side point of view. When all of this comes together, only then a successful project is built. Now, what are the common challenges? Too many stakeholders, each with different expectations. Users describe needs vaguely or incompletely. So, this is also one more thing. Users describe needs vaguely or incompletely. So, when the requirements is not specific enough, then again misunderstandings, assumptions, cases starts building. Many stakeholders aren't technical, so communication is tricky. Sometimes there is no existing system to learn from at all. Okay. Techniques used to collect requirements. How can we collect the requirements from whoever are using it or whoever is building it? How do we collect the requirements? Interviews. Talking directly to users to understand their needs in detail. Question is collecting input from a large group of people efficiently. We ask opinions. If we make a survey form and we send it to multiple people, each one will give their opinion in the questionnaire. Observation. Watching how people actually use the existing system. Workshops, group sessions where stakeholders discuss and refine needs together. Prototyping, building a rough mock up so users can react to something concrete. That's what when I told you. When you just give vague or unspecific requirements, build a small prototype. Then they can again further suggest if they want any changes, what kind of changes, what kind of advancements is required. All of that can be refined in the final project. Studying documents, reading existing forms, reports, and manuals before talking to anyone. All of these are methods or techniques to gather requirements. So, a real example, to automate office work in a college department, an analyst collected existing paper forms, interviewed staff about their daily tasks, and studied how work currently flows from person to person, building a clear picture before adding a single requirement. Okay. So, why do analysts often study existing forms and documents before interviewing anyone? It's because forms show exactly what data goes in and out, giving a head start before talking to people. This is also wrong. This is also wrong. So, documents give analysts a preliminary understanding so interviews can focus on clarifying details rather than starting from zero. Absolutely important point. Just clarify, just add on information, just rectify it instead of starting from scratch zero. The next topic is requirement analysis. Previously, it was requirement gathering. We understood how do we gather the requirements. Now, think of a jigsaw puzzle where everyone only has handful of pieces. Some pieces overlap, some don't fit together at all, and some are missing entirely. So requirements analysis is the process of laying every piece on the table and figuring out how they actually connect before anyone starts building. So what are the three problems is ambiguity. A requirement that can be read in more than one way, usually because of vague words like fast, high, or user friendly. The system should respond quickly. Quickly compared to what? Like that. It's incomplete, right? Inconsistency. Two requirements directly contradict each other, often from different stakeholders. Correct? We discussed that if multiple stakeholders are there, then expectations become different. So one might say allow guest login, others is only registered users allowed. Again, this is a contradicting. If you start building based on if you start building the project based on particular requirement, then the other stakeholders affected. So all of these are put together down, discussed first, clarified first, written down properly. All official things are done before anything starts to get built. Incompleteness. Something important is simply missing, usually because nobody thought to mention it. System stores username but nobody asks for contact details. This contact details is entirely missing. Just an example, okay? So how do we fix this ambiguity? Replace vague words with precise measurable numbers. System response should be fast. Instead of that, response time should be under 2 seconds. How analysts detect issues? Reviews and inspections of the requirement document. The requirement document which is written, those are reviewed. Is there any incompleteness? Is there any inconsistency? Building prototypes to reveal gaps in thinking. Prototype is not the final project, right? It's just a miniature version. It's just a demo version, which can be again further improvised, redone. Okay, so direct discussion with stakeholders to clarify and validate in case of inconsistency. So the system should respond quickly is an example of which problem? It's a problem of ambiguity because quickly isn't measurable. Quickly is a vague subjective word. Different people interpret differently. Quick for someone might be 10 seconds, quick for someone might be 2 seconds. Depends. The next one coming to functional requirements. There's two requirements, functional and non-functional. We'll be discussing both of them. So these describe exactly what the system must do. Its actual behaviors and services. This is going to tell the system what are its behaviors and services. So think of a restaurant menu. It lists exactly which dishes are on offer, butter chicken, margherita pizza, without explaining how the kitchen actually cooks them. Functional requirements work the same way. They list what the systems offer, not how it's built internally. What is the system offering? What does it do? That's it. Not how. All of it doesn't come here. What is only the question in functional. What function does it do? That's it. Okay. So high level function. A high level function is a complete meaningful task that user directly asks for that adds real value. For example, an ATM withdraw money is a high level function that user explicitly requests it. Print receipt is not. It happens automatically as a part of withdrawing money. The user never directly asks for it. Small example. So every function has three parts: input, processing, and output. Input is the data which is given by the user. Processing is the system works on it. Output is the results shown to the user. Search book, input, book title. Processing, which is matching the title to the data which is given. Output, list of matching books. Okay. So functions are not always one shot. They are a conversation. So a high level function often needs several rounds of input and response, not just one input and one output at once. Insert card, then we enter pin, then choose amount, system checks balance, then the cash is dispensed. Each step here can be even read as its own sub requirement. This makes big functions much easier to document and test. So why is print receipt not considered a high level function in ATM system? Because the user never directly requests it, it happens automatically inside another function. Okay. A high level function is explicitly invoked by the user. Is the user asking print receipt? No, it's automatically coming after the cash is dispensed. So printing a receipt is supporting step inside withdraw money, not a function on its own. Small example, don't confuse too much. Next, coming to non-functional requirements. In non-functional requirements, it is telling what the system does. No, sorry, how the system does. Functional was what it does. What it does. It's not showing inside how the pizza is made or how the butter chicken is made. Okay, this non-function is simply telling how it is happening, how well it does. Think of buying a car. It can drive is a functional requirement. Every car does that. But how fast, how comfortable, how fuel efficient, that is given by the non-functional. They are about quality, not just capability. Capabilities it can drive. Qualities how well, how comfortable, how fuel efficient. That is non-functional. Okay. Performance how fast and efficient. Example process 500 transactions per minute. That's performance. Security protects data from unauthorized access, logins, and encryption. Safety prevents harm during failures, auto shutdown on overload. Reliability works correctly over time, 99 to 99.9% uptime. Usability easy to learn and use, simple, intuitive interfaces. Maintainability easy to fix bugs and add new features after launch. Portability runs on different platforms Windows, Linux, web. External interfaces how it connects to other systems, APIs, databases, sensors. So just function and function let's compare. Function will describe what the system does. Non-function will describe how well it does. Example user can register and login is functional. Login should complete within 2 seconds is non-functional. It's describing a quality, how well it is happening. If missing a feature simply doesn't exist. Here, non-functional, the feature exists but performs badly. Okay. The system should have 99.9% uptime is an example of which category. It is mainly about reliability. How much uptime? So it is reliability as we saw. Next, coming to the last part of today, that is the SRS, which is software requirements specification. The formal document where every requirement gets written down and both sides agree to it. Think of it like a signed contract before renovating your house. It spells out exactly what will be built. There is no, but I thought you meant like that. All of that is not there. That's why we require this software requirement specification document. That SRS plays the exact same role between a customer and a software team. Once approved, it becomes the official agreement. Why should we write this as we already discussed? It acts as a blueprint for design, coding, and testing. Serves as a contract between customer and developer. It should not be like after the developer has done everything, the customer is like, oh no, I wanted something else, all that. That doesn't work like that. That should be done in the requirement stage itself. That should be finished by prototyping stage itself, not after the whole thing is done. Help project managers estimate cost, time, and resources. Absolutely, that's very important. You can't because only when the requirements is given, you have to understand. Okay, we require these materials, this much time, this much cost is going to be put, this much effort, these many people. All have to be understood by project managers in the beginning stage itself by the SRS document. Let's testers write test cases directly from the requirements. Catches missing or conflicting requirements early before expensive rework. What are the signs of a good SRS? Concise and clear, no unnecessary details, only one possible interpretation. There is implementation is independent, describes what is needed, never how to build it. Remember, implementation independent. It is only going to tell what has to be built. How it is built, all of that is not written in the SRS document. Traceable, every requirement can be linked to design, code, and test cases. Modifiable, easy to update as requirements evolve. Verifiable, every requirement can actually be tested. Signs of a bad SRS: over specification, sneaking in how details, naming a specific database instead of just describing what is needed. Wishful thinking, describing features that are unrealistic or practically impossible to build. Forward references, referring to something explained only later in the document. Confuses the reader. Noise, irrelevant information that has nothing to do with the actual system behavior. All of this is a sign of bad SRS. An SRS says use a MySQL database with B-tree indexing. What's wrong with this? It's saying how to do it. In an SRS document, we only want what has to be done. We don't want to know how it has to be done. That's left for the developers, right? So this it's over specification. It detects how to build, not what is needed. A good SRS should describe the system as black box, what it needs to do, and leave the implementation choices like database type to the designers. Okay. So one final challenge, if this 20 minutes has been helpful to you, if you have understood something, try to answer these questions. Let's do it together and then we see. So why does requirements matter? Fixing a requirement error is cheapest when caught during the requirement phase. Absolutely. Requirements gathering. Watching how people currently use the system is called as observation. Requirements analysis. Two requirements that contradict each other is called as inconsistency. A high level function must be explicitly requested by the user. Non-functional requirements. Login must be completed within 2 seconds is an example of performance. In the SRS document section, we have the question. Naming a specific database in the SRS is an example of over-specification. So I have been able to answer all 6 of them. That means I have understood what I am teaching. So in case you have also done the same, congratulations. And thank you so much for watching this video. See you in the next one. Hope it has helped you. Thank you. Bye-bye.